The diagram shows the curve and also a line y equals to -5 with the 2 point of intersection A and B. Now we got to find the volume when the shaded region is rotated through 360 degree about the x-axis. So when I see the x-axis, I will directly go to the x-axis itself, and I know that I am going to rotate this shape 360 degree. Now when you rotate, let's see what's exactly happening. Let's do the easy one. See, it is always limited by some boundary over here. Will you be taking this entire line and then rotate about the x-axis? No, you need to bound it between -1 and 3. So we only take this and we're going to rotate. So when you rotate, what kind of solid will you get? See, you're going to get something like this. Okay, and this shape is technically the cylinder itself, right? See, what is the gap here? The gap here is 5. So it means the gap here also has to be 5. It's a symmetrical rotation all the time. Okay, for that I am going to just draw it. Draw the solid down here. We have this. Okay, cylindrical in shape. Where is the x-axis? The x-axis is this particular middle portion. Okay, it is coming out from here. Let's make it more symmetrical. What is this point over here? Can you see that is x exactly -1, and this one over here is x equals to 3. So you know that the volume of a cylinder is pi r squared h. Let's just look into our radius. Where is the radius? The radius is over here. And then what is the height of the cylinder? It's this particular value. Can you go and find for me what is the r and what is the h? You try to bring your imagination here. So when you rotate, this is the radius. What is the radius? It's exactly 5. What is the height? That height is from this point to this point over here. Okay, can you see? It looks exactly like this one. Radius and the height over here. What is the height? -1 to 3. That simply means 3 unit here and 1 unit here. I'm going to get a height of 4. Okay, now let's go to the curve. I'm going to take that ugly curve and I'm going to rotate about the x-axis again. Will I be rotating the entire portion of the curve? No, it must be bounded by -1 to 5. Okay, where is the curve? Go and locate. Okay, so what will happen when you rotate this? What kind of solid will you generate? What kind of solid will you generate? Okay, let's try to make an illustration using the red color here. The dotted means it's exactly at the back. I hope you can see what's happening, yeah? You view it as a 3D shape. You view it as a 3D shape. Okay, not so much of a oval shape, but more or less like that. Now, what I want you to imagine, I want you to tell me where is the solid that you are looking for. That solid is this portion over here. See it as a 3D. So, now, how do you find the entire shaded region's volume? First, you take the volume of the curve, okay, and then you minus the volume of the cylinder. So, to do the curve, we integrate from 3 to -1. What is our y? And it needs to be squared. Dx minus pi. You already know your radius is 5 and your height is 4. Okay, what could go tedious now? Look at this. This is a non-linear. So you don't have a specific formula to integrate. The only way that left now is to expand this one. So let's try to expand. You can do one by one. Take your time. You can pause the video at this point and do it. Okay, I'm done with the first layer. I'm going to go to the next one. I'm going to go to the last one now. If you see the way that I write, I try to pair the coefficients according to the variable. I have x power 4 and then for x cube negative 12x squared. It's easy for me to do the operation when I write it like this. So let's go and integrate all of these with respect to the x minus, that is going to be 25 times by 4, 100 pi. What is 100 pi? That is the capacity of the cylinder, or you can again pause the video, do the integration on your own. Increase the power by 1, divide by the new power. Increase the power by 1, divide by the new power. Input your limits. See, we can modify all this here. It's just x power 4 and then 4x cube, and then this is just going to be 16x squared. This will make your substitution easier. Pause the video and then you do the substitution on your own. Okay, this is a scenario where you know what you are exactly doing. Some of you could make careless mistake, and let's see what are the careless mistake you're going to do. The first approach is, many of you would have applied the areas concept of finding using the top minus bottom approach. See, when you're finding the area, you always take the top curve and you minus the bottom curve. So, but when you're doing for the volume, you cannot do one go. See, the common mistake is you will take the top, you minus the bottom, and you will square it one go. See, you cannot do this. Why? You will end up with a different curve, and that particular different curve, of course, will give you different solid. So the real idea here is, you can still do top minus bottom, but you take the top curve, you square it. Then you minus bottom squared one. You cannot do top minus bottom squared. It's a common misconception from the idea of area. So let's see whether the student do this frequently or not, and if yes, how do they do that? Okay, this one. You look at this particular error done by this student over here. What the student has done, the student is taking top minus bottom and then directly squaring the entire expression. What did we get just now? This was our curve, right? And then what was our line? Our line is y equals to negative 5. So this particular student took the top curve and he minus the line. Okay. So, and he is getting minus 3. And if you compare here, why is the student getting the negative of yours? He just simply took the line minus the bottom. which is quite incorrect as well, another misconception. But you cannot fall into this particular trap. And then the next one, let's look at the next misconception. What is that? He did only for the curve. Okay, what region he got? He got this whole red color region, but he did not remove the cylinder. So you have to watch out. You have to watch out. And then the third pitfall or misconception is wrong expansion. Of course, you can make algebraic mistake and you get confused between the radius and the height of the cylinder. You tend to take the radius as the height and the height as the radius. So a nice sketch like this would definitely help you during the exam.